welcome again for this panel. Welcome to our awesome speakers. Thank you for being with us today. So let's debrief. What happened? Where are we now? Has the world changed? What do we expect out of Dencun? So maybe let's first start with a quick round of who's who. So I'm Henry I'm at the Starknet Foundation. Declan, do you want to say a few words?
Testing.
Yep.
You hear me? Yeah? Okay, cool. Hi, everyone. So I'm Declan Fox. I'm the product lead at Linear, also one of the founding members. So I'm also from London as well. I've been with the team since the very beginning. And yeah, super excited with the upgrade. It's going to be a big moment for rollups. Linear is an Ethereum rollup, so we leverage the L1 data availability, and data availability is the majority of our costs so far. So we're not activating it just yet today. We're going to wait a couple more weeks. But yeah, super excited to kind of see what the benefits are with this new fee market and see what we can do on the L2 to actually benefit from this upgrade in terms of prices for users on Linear and on L2.
Super exciting. Thank you. Ohad.
Yeah, I'm Ohad. I'm product manager at Starknet for the last 4 years. Handled a lot with data availability in Starknet, many other stuff.
Thank you, Jorik.
And I'm Jorik. I'm CTO, co-CTO at Nethermind. And actually, my other CTO is the one who's been working the hardest on making sure that Dencun has been stable. So for us, this is a very pivotal moment.
Nice.
And on my side, I've been very excited to see how Starknet is going to utilize this technology. So it's a really beautiful moment in Nethermind for the synergy between everything that we're doing and seeing it all go live at this moment.
Yeah. Thank you. So maybe let's start with setting the stage a little bit. What is 4844? What is Dencun? What exactly happened? What did we activate here? I don't know if any of you want to take a jab at it. Yeah, sure. Go ahead, Declan. If you want to explain a little bit, like, what is it about? What are blobs anyway?
So I'll just give a high level. Basically, today, or up until today, previously rollups would use the opcode call data to store their transaction data. So L2s leverage L1 for their liveness and security. And to do that, we have to leverage this sort of opcode called call data. And that's very expensive, sort of 16 gas per byte, not very efficient, and it's not really built for rollups. So what 4844 does, also known as proto-dank sharding, it essentially breaks out that storage into like a new sidecar. So we have these new concepts called blobs or blob space, and in each Ethereum block, there'll be a sort of target of 3 blobs per block with a max of 6. And these blobs are separate to the main block in terms of how much they can store. So if there's less demand for these blobs, then the fees will go down, very similar to how EIP 1559 works with Ethereum block space. And so as the demand increases as well, like we get a sort of new exponential fee market. And the whole point of this is basically to break out the actual transaction fees happening on Ethereum. So they get their own sort of dedicated space now if you're doing like a Uniswap call on L1, whereas rollups or other consumers of blobs and call data can actually have this dedicated fee market and blob space to either build security into their rollup or other use cases.
But why is it cheaper? Like, why can it be cheaper? Is it just a separate market, or does that data has a different property as to what call data was doing before?
So basically, it's a different market, right? On Ethereum, you wouldn't want Ethereum blocks to be too large because it's very, very cumbersome for the network, and it means that Archive node needs to save them for perpetuality. Those blobs are basically another resource. Validators of Ethereum are required to store it only for a very short period of time. So it's less heavy on the network, and this is what allows it to be much cheaper.
Okay, so they have a shorter shelf life. Is that correct?
Mm-hmm. Yeah.
But, I mean, what the fuck? I thought blockchains were forever.
Oh, not everything's forever. It's an important question in that I feel people should have an open choice of what they want to store forever and what is not necessary to store forever. And a lot of people make the mistake with DA. They think that data availability means data storage, and it doesn't mean this. The property that you're giving people is everyone has the same access and the ability to get the data in order to work. It's a dissemination protocol, really. Like, I want this information available for the next 2 weeks and make sure everyone can read it. I make a news article and I want to make sure it's hitting every single major publication and everyone can read it, even though we might not want to remember it forever. This helps a lot in coordination games, and it helps in the case of a smaller rollup like Starknet that wants to be able to say every member in our rollup has seen the new update and is currently at the head of the state, but we don't need Ethereum to remember that on Starknet's behalf. It's an open question, and people actually debate it a lot whether or not that's a good security trade-off, and I think this is a fundamental thing to have, and I'm in support of it in Starknet, to be clear. But
I wonder if any of you have some thoughts around, well, I mean, what you're describing really is like, it's kind of a paradigm shift, or at least it's a big, different way of looking at how we interact with blockchains, because I think for better or worse, and we can debate whether this assumption is a good one or not, but I think for a long time, for a lot of people, the assumption was as long as you have your key, as long as you have your seed, whatever, you can download the whole chain, get access to all the data, and keep interacting with the chain. This changes this assumption, correct? So I'm curious, like, do you see user guarantees changing? Does that change the security of the chain and the level of access that people have for their funds?
Yeah, I think, for me, I think it's a much better architecture because basically we have the data available for the time needed to actually verify it and have strict global consensus over that data. In the case for a rollup, you just need it for enough time to either verify a zero-knowledge proof or submit a fraud proof in the case of an optimistic rollup. And then you can rely on a sort of typical like P2P network for actually just securing the data historically. And so that's a much better way because then you're putting less burden on the nodes to actually store the data for the long term, which can be really expensive and probably is one of the worst priced pieces of the EVM today. And then you just rely on like typical decentralized storage or there'll be many different options for actually storing the data. And as long as there's at least one available so you can recreate the state in the case of a rollup, it's a much better path for us to have scalable L1, but also an L2 that really separates the consensus from the actual storage.
I agree, it's leaner, but I mean, technically, cold data will be here also. It seems like you will have strictly higher property. Is it the case or not?
So say again?
It seems from what you guys explained that cold data will have strictly better properties because it will be kept. Is it the case or not?
No.
Jarek,
if you want to take it.
I mean, allegedly, yes, you could say cold data is forever there, but in practice, people that would care about the data in the blobs, for example, in Starknet, the Starknet full nodes, if neither is right, they would get the data, they for sure would save the state, they would save everything. So actually, the guarantee that the data is there is promised by the continuity of always there is some Starknet node that is operating. Obviously, if at any point in time we don't have any Starknet node to track and save it, we have much bigger problems.
So I think it's an interesting one because people don't fully understand how Ethereum works on this case either, right? Like, I can join the network by adding my key and staking, but no one's actually incentivized to give me the data. They give it to you as a favor, right? Like, because they want to be able to make sure that the network perpetuates. And you can buy it from an RPC provider if you want to, but there's no incentive around the syncing mechanism whatsoever. You actually are not guaranteed that you can download the entirety of Ethereum because you want to tomorrow. But because there are 800,000 validators, it's likely that someone will, right? This is more of like an AnyTrust model, and that's also here in the 4844. That's my take on this. If I'm very off on that, I'd love a
that's interesting. It's an interesting one. You're right. There's no guarantee that you'll be able to download data that somebody will send it to you, but you're hopeful that someone will. Interesting. Well, I think it's a good segue into another question, which is, okay, so now that, Ethereum will not be used for quote-unquote data storage, which was kind of used for, it will be used for data publication. So we have a certification that data was put on a bulletin board and everybody had access to it for a week. What happens to this data afterward? Is there a business model around storing blobs? Is there, do we just expect the data to be stored?
Yeah, I think there's a few different options when it comes to storage. I think as a roll-up, at least for this bootstrapping phase, we're going to be storing the backups ourselves. But also there's going to be sort of typical centralized providers. You can imagine all the sort of big RPC providers, explorers who will also be having, archival nodes and storing this data. And then as I mentioned earlier, you've got the sort of typical decentralized peer-to-peer networks. Like you could dump that data on IPFS or something as well. And so you have these sort of multi-layered options to make sure that you can always retrieve the data. The one thing I would say is sort of tangential, but I wanted to kind of catch on to the end is I still think for a while we'll need the cool data opcode because ultimately with blobs there is a fee market there, and if things get really crazy in terms of demand for those blobs, there actually is definitely an alternative where you could still post your batches as cool data, and it actually might be a rational decision because it turns out to be cheaper. If for whatever reason you need to publish the batch at a specific time to try and get earlier transaction finality. And so keeping, at least for until we increase the specs for proto-dank sharding to full dank sharding, and people can always rely on blobs, I think we'll always need that opcode for call data to be there and to be cheap as well, because I know there's talks about actually expiring call data or even increasing the gas per byte for call data, so something like 64 gas per bytes back up again. So just want to kind of call that out as a big threat, especially when you see things like blob inscriptions, or I was on a call earlier and someone on Gnosis is already putting memes and podcasts into blobs. So we're definitely going to see a lot of different use cases for this kind of new format.
Thank you. Ohad, I mean, where does the data from Starknet goes? Who keeps it?
So obviously all the full nodes of Starknet are always aware of the state. Currently they are even not aware of it because they read Ethereum, but because the sequencer tells them. But the data that we publish on Ethereum is there as a backup. So if for some reason the sequencer isn't doing that, they can still synchronize versus it. I think that in general, storing the data in the blobs for in perpetuity is very app dependent, right? Because any app could use blobs for different means, and at least for the rollup case, I don't see really any market for storing this data long term beyond just the rollup robustness that is given by the full nodes. For other applications, maybe, but they're already like general storage solutions such as IPFS. So I don't think it's a huge change.
Okay. And for Starknet, Starknet stores state diffs, right? And so it sends state diffs as blobs. So does that mean that when you synchronize a Starknet node, you only need the latest state and you need to match it with what is on Ethereum, but you don't really need the history of all blobs anyway, right?
Yeah, you just need to have some previous state, right, to start from, and then you go state diff by state diff and you can apply.
But what I mean is, like, even if you don't go state diff by state diff, you could just start from the latest state, right?
Yeah.
So you don't really need to store blobs anyway.
Yeah, unless there is some, yeah, you don't need to store the blobs, you just need to store the state, that's all.
Okay. Do you think there's a value, so, I mean, if it's used for data publication, rollups such as Linea or Starknet, I mean, if you send state diffs, at the end of the day, what nodes care about is the state. You don't really care about, I mean, you don't technically need the transaction history. But some people may want to have it, and some people may attribute a value to it. Is there a point in publishing transaction history as blobs? Jorik?
Well, I strongly agree with this in some sense.
Sorry?
Yeah, is this on? Yeah, I strongly agree with you that there is a point to doing this. First of all, you have a lot of data scientists who want it. You'll have archivists who want it. You're building an early version of the future financial systems. They're going to want to study this data in the future, right? But on the other hand, transactions, the transaction history, or if you publish them earlier, you can come to sort of a faster finality by going through the blobs, right? If you wait for a long time to do all of the state diffs and you aggregate over a ton of blocks to publish a state diff, then anybody watching L1 will have to wait for that to say that it's finalized. So there's a small way that you could optimize for finality by going with transactions and blobs. But yeah, I think it's already the case that it's hard to prove that a transaction actually was in the state in Starknet, and I think this would be a very useful feature to have in the future. So if we could do it through blobs, that would be amazing. Yeah.
Interesting, thank you.
Yeah, because I can speak. So Linea went down a different path. Like we post transaction inputs, which is different to Starknet, who does state diffs. And people often go to me like, "Oh, you obviously did that so you could get like faster transaction ordering finality." But really, that's like not that true. Like it's still a very soft finality until the proof is like verified. That's when you can only really trust the L1. So I never really sort of bought into that. At least for us, the reason that we did it was just because it's like easier in the prover. Like it's more lossless if you just have the transaction inputs for when we designed the prover. And that's like literally it. But at least for us, like we always felt that if we felt that there was a benefit of moving to state diffs, and again, we managed to get compression that's kind of like as good now. But I think there's still like it's still up to developers to actually design for state diffs. Like if you're doing an Oracle, you need to be using the same storage slot. No one's really doing this yet, but like that's when we would also move to state diffs and get that benefit too.
Super cool, thank you. So we talked about, updating on-chain, like publishing the state of rollups, publishing transaction history. What kind of other weird stuff will come up in blobs? Like, what do you think those things will be used for? Any guess or any fun ideas?
Well, yeah, like I said earlier, there was like memes already and podcasts on blobs. on Gnosis.
Like publishing a full podcast?
There's a full, yeah, it's like split across many different blobs. You can go on it now, it's like blob.fm. And yeah, it's crazy, like it actually works. But again, as a sort of, like product lead for a major roll-up, like as a big consumer of these blobs, I'm thinking, oh no, that's like, another big amount of congestion probably going to come on these things. So that's a little bit of a concern, but it's also kind of fun to see these use cases. And blobs today are going to be the cheapest they probably ever will be, as not many people are using them. I think the other interesting thing for me is there's a lot of these new L2 app chains spinning up, right? And they're sort of, minimal activity. And for them, they have a decision whether to sort of hold off publishing the batch to make sure they fill it up because you have to pay for the full blob, or do they try and like pay early and then just are not very cost optimized? And so I kind of hope to see at least some services which aggregate all of these different publishers of small amounts of blobs into like the big blob, and that just means there's going to be less congestion for larger universal providers like Starknet and Linear.
Interesting, thank you. Any other idea?
I learned to be very careful when you talk about the next thing in crypto you didn't see coming. But
I've actually thought about it a lot, and I still can't see strong angles. Like rollups is definitely the most obvious for me because it's there. So that's not a very intelligent thing to say. But
Inscriptions?
Inscriptions possibly. Also, in a weird way, and this is already doable with other technology, but like whistleblowing is kind of protected by this.
Oh, interesting.
Because you could go to IPFS and say this data is available, but usually IPFS is only pinned on other servers if people access it, so you don't actually get the distribution. But if I did a whistleblow, committed to it on chain, and then put it through 4844, I'd be very sure that no one could take it down in the window when it's most important to have it out.
You heard it here first. Next time you go to a hackathon, new cool dead man switch contract you can build.
Thank you. But yeah, no, I'm actually... I think this is going to be one of the ones where like the Eric Walls of the world come in and do something really surprising that we didn't expect, and like the 4844 price just goes straight through the roof because everyone starts using it for that. So yeah, I'm excited to see where it goes.
Well, I mean, and maybe it's a nice transition into price, maybe, because how do we expect the price of blobs to evolve? I mean, if the price of blobs jumps through the roof, and it gets more expensive than what cold data is today. I mean, I would find it surprising that this happens, because if there were people willing to pay more than cold data today, then they would be already consuming cold data today, no? So I don't know, do you expect that this will actually lower price? Declan, you were careful about, you're mentioning that with Linear, you're considering whether it's advantageous or not. Do you expect the market to be very volatile, very high, very low?
I think eventually, yes. I think whilst we still have roll-ups sort of activate using blobs, there'll be this really nice sweet spot for like the next few weeks. But I do think as people start to leverage this blob space, we will get a lot more volatility, especially because if you look at just like typical activity across blockchains and in the Ethereum ecosystem, it's very cyclical. Like when the US wakes up, there's lots of activity. When it goes to sleep, it kind of goes down. And so you can imagine there's just scenarios where people are all trying to publish, blobs at the same time. And again, I think my analogy is always that like roll-ups are kind of like commodity traders in a sense, very similar to sort of like oil and gas industry, where you're like selling block space on L2, buying block space or blob space on L1. And so I think like until people get really smart about the timings of blobs and these systems become more sophisticated in their coordination, I do expect to see scenarios where the blob price increases exponentially over the call data. Then again, people, if they can, they will use call data and it will come down to an equilibrium. But I do think it will be volatile for a bit. Eventually we'll increase the specs so high on Ethereum on the L1, and there's a few hurdles to get there, but like then it will just be a case of hopefully enough capacity for everyone.
Thanks. So you expect the market to be exuberant, but eventually self-regulate and actors to get better. What about you, Ad?
yeah, I agree that there would be a lot of volatility in the blob price, but also around just the L1 gas price, right? That could be in close synchronization with it. Obviously, there could be spikes also in the ratio between the two. Like if many applications already created the transactions that would use a blob and now they need to redo a bunch of stuff or to get stuck with the decision to use a blob, right? So temporary abnormalities could happen. I think the more interesting question though is not the volatility that's obviously going to be high, but the expectancy of the price, right? Is it eventually going to be just more cold data and roughly the same price, or are we going to see order of magnitude of cost reduction? Um, I think that we will not see orders of magnitude of cost reduction. In the most optimistic case, one, because even if we see initially more than one order of magnitude, it just means more use cases that use a lot of blob data, and then more usage, and then unless the Ethereum Foundation gets a decision to increase the number of blobs, the price would go back up until there is some, I would say, less than one order of magnitude ratio between the two.
Interesting. What about you, Jarek? Any opinion?
Well, it's an interesting one to analyze because, like, yeah, theoretically, call data should be the max price, right? But if you reach this level, it doesn't mean that everybody has the ability to switch quickly. So there are instances where this could definitely go higher than call data, because it's not just like the network that needs to switch over. It's all the full nodes. It's all of the extra people reading this data in real time, trying to track everything. That whole system needs to update. And doing an emergency pull from one to the other is hard to orchestrate, or needs a lot of engineering work to make sure that it happens stably every time it happens. So it's not that market can easily stop using 4844. And the other thing that 4844 has is it has a base fee mechanism in it. So it has a stabilization on the volatility in the same way that gas prices have. So it won't be as chaotic and messy as like the original launch of Ethereum, or the sort of like that moment when it's really started getting a bit mad on the volatility of gas price. So like we should see a stable growth probably over the next while, I'm hoping, from the base fee mechanism. But we'll see how well it works in this case.
Thank you.
Maybe just to follow on that, like actually, so a hot take is like I think optimistic rollups in particular are in a very tricky spot because they have less of a flexibility to time when they can like finalize or when they can publish a batch or blob to L1. And so they really have to ride whatever the L1 gas price volatility is, whereas, you know, a ZK rollup can actually start to like delay that and be a bit more careful about when it publishes to bring down their L1 costs and therefore pass those prices on to users. So I can imagine a scenario very soon where like the optimistic rollups that remain probably end up buying like L1 gas derivatives just to have that predictability, whereas the ZK rollups can be a little bit smarter. And for example, when, you know, L1 gas prices go down in a sort of typical time frame at night, you know, then they'll actually choose to like settle and pay their L1 batch costs because they don't have to be as quick to send the batch to L1.
Yes, being provable gives you a bit more flexibility in how you interact with L1. Interesting. A lot of innovations that were done on Ethereum eventually percolated to other chains and other L2s. Do you expect L2s to implement their own implementation of blobs of 4844? Ohad?
Eventually, maybe yes, right? Like when Ethereum did it because it became hub of a lot of L2s that are operating above it. And the demand for that was really, really great. I think that L2s are yet to be in the stage that this is their most immediate concern. They are too expensive because people trying to publish data on top of them. We have many challenges to solve before this. In Starknet, for example, call data was absolutely free until recently. We bumped the price to something very, very minimal to prevent it being totally free, right? But I still don't think that this is the use case of Starknet, right? Sending a lot of data without any major execution on top of it, or in any other L2 chain. In a few years, when we have L3s and so on, maybe this will change.
Yeah, but there's a saying about premature optimization that it's really cool, right? Or but I see your point. So it's a bit too early. This is not the use cases of L2 right now.
Yeah.
Right? In your opinion?
I don't think it's a good idea at all.
Okay.
In the sense that, like, the only reason you do DA is because you say, I have a large set of nodes, and I know that they will participate in this protocol. You're not like gaining Ethereum security by doing a DA on the L2. At least I don't see a design that allows for this, but maybe there is. But then you're just saying, like, okay, my smaller network is also providing DA, but you're competing with DAs that have the same size, don't inherit the security from Ethereum anyway because they are their own DA networks and are specializing for this already. So it doesn't look like a viable path for me to go from L2 to L2 plus DA, when in like 10 years from now we'll have like uncountable number of DA layers already competing. Unless I'm missing the Ethereum-centric narrative here, but yeah. No.
Thanks. So you mentioned other DA solutions. I think it's also an interesting topic. So Ethereum is now a data availability layer like other competitions. how does Ethereum compare to other solutions that are on the market, and what are advantages and disadvantages to using it? I don't know. Linnea, did you consider using other ones?
Yeah, it's a good question. For us, like, we always felt that Ethereum, not just the values, but also the security and technical properties made the most sense for what we were trying to achieve. And I still think with 4844, that just makes it even more attractive. I sort of look at some other projects which have maybe looked elsewhere for their data availability needs, and I think that's quite a painful trade-off, because I understand leaving for cost. You know, you want to provide cheap costs to your users, and I think 4844 starts to enable that, and we can hopefully go further. But ultimately, if you're looking to have the L1 with both liveness and security, you want to make sure that is as secure as can be and credibly neutral as can be. And I just don't think there's any other DA service out there yet that can really offer what Ethereum offers in that regard. And so I really think that not only because it has a better product to offer rollups, but the fact that it has network effects of many rollups already opting in and that sort of same root of trust, I feel like this is Ethereum's sort of like game to play with the DA.
It's not about the buffet, it's about how many people are at the buffet.
Exactly.
Makes sense. What's your opinion on this, Ohad, and I guess probably on volition and publishing data off-chain or off-chain?
So, like, obviously we are building on top of Ethereum, right? We're proving the correctness of the execution for Ethereum, and eventually the data availability also, you can't publish it anywhere else without hurting, to some extent the security guarantees you give to the users. Maybe that's okay trade-off for some use cases or for some users in some situations, which is, I think, very understandable, and we are exploring ways, as you said, with Volition, to make it flexible. So some users that store a lot of funds and very care about security would use Ethereum data availability, while other use cases that are very, very low nominal impact or very, very short impact in time, like repeating price updates from Oracle, don't need to use this fee. But as like the default or the most secure option of the network, we can't really do anything less than posting on Ethereum. It would make no sense. It would make, like, because the security of data availability, in the end, impacts also the security of the network.
Thank you. Jorek, do you have any opinion on the cohabitation of data from various data availability chains within the same rollup? Does that make sense? Does that just give more headaches to our security auditors? Or,
Sorry, I don't.
like, if you have a rollup that publishes some data to Ethereum, some other data to, say, Celestia, or off chains entirely, how do you make those co-inhabit, and what are the security implications of this?
Yeah. Different parts of your protocol might be depending on different security parameters. And I think it's very easy for a developer to get their programs into irrecoverable states where they're expecting something to be on one layer, but that one goes down, and now they can no longer interact with some other layer. So I think generally it's a bit of a nightmare for an auditor if you do this, because it's hard to track that many different places to store the same information. Because like usually there are many tactics here, such as like you keep your main account balance on the safest one, and then like you keep smaller derivatives of it on other chains or on other DA layers. But then like the user still needs to track where that data is. The applications need to factor in that they might need to move them around if there's not enough, and it just becomes so much more complicated to work with that it opens a lot of vectors. It's a bit vague, but like basically the management of state is one of the big problems, and you just expand that like characteristic.
Yeah, so I mean, I understand what you're saying. It's like more complexity brings more risk, and it makes it harder for, I mean, there's a lot of tooling and solutions to invent for users, for dev and everyone. But I guess you could put that same argument against Dencun itself, right? It's against 4844. Is Ethereum getting too complex, in your opinion? Dencun. I'm sorry, Declan.
Yes, another good question. I think it's complex in perhaps the tooling, and again, like as we were looking to implement this for Linear, like a lot of the tooling wasn't quite there yet. Like even just your typical developer tools, like for the EVM, like we had to really ask or like kind of force our way through it. But I think in terms of the complexity of only having one system, like your security of your system and liveness to your system is sort of the weakest link, and to have only Ethereum to think about in terms of a sort of system architecture perspective definitely simplifies things in the sort of longer term. So,
Ohad?
I agree. I don't think it's too complex. Obviously, it's paving the way to new things, and there are some hurdles. And integration wasn't always easy, but in the end, I think it's an elegant solution to the problem.
All right. Folks, I think we are done. So again, Yorick, Ohad, Declan, thank you for coming and bearing with my questions. And have a good day.
Thank
thanks
you.
for having me. Cheers.